Hello everyone and welcome to the NPTEL course in Pharmacognosy and Phytochemistry. This week we are learning on different phenylpropanoid derivatives. So far we have finished flavonoid derivatives. In this week we will dwell on two more classes of phenylpropanoid derivatives, and this session we are going to learn about lignans. Now what are lignans? So lignans, maybe you heard this term lignins and lignans. So lignans are chemical derivatives. They are formed from your phenylpropanoid pathway and they are biosynthetically derived from shikimic acid pathway. So we have known that shikimic acid pathway gives rise to different amino acids, and the most common ones being your phenylalanine and tyrosine. This phenylalanine and tyrosine contribute to your C6C3, and this C6C3, if you see here carefully, two such units, if they join to each other, they are called as lignans. So lignans basically are dimers of C6C3. We can just write it as C6C3 into 2. Okay. Now what happens is, certain times during the biosynthetic pathway, in case of just dimerizing, your C6C3 may polymerize. So when that happens, let me just put it as C6C3 into N. Okay. Now when this happens, they are called as lignins, and these are called as lignans. So little difference between two, your lignans will be a little lighter weight. They will be your C9-2-za, C18 kind of compounds or their derivatives, whereas lignins would be very polymeric in nature. They will be polymerizing like we saw in your tannins, but more CC linkages are found here. If you remember, lignins are the ones which gives rigidity to the plant tissue. So you know your plants when they are born are generally soft, but if you check your wood is pretty stiff, and that stiffness is coming from the lignin deposit. So lignins are something which gives you more of a mesh network kind of structure which supports the cellulose and gives you more strength to the trees, whereas lignans are just dimers. They are little low molecular weight, just consisting of about 18 carbons or so, around that range, because they might be derivatives, they might form adducts with other compounds. So comparatively low molecular weight, and they have a different role to play. Their basic role in plants is to carry out more of a defense functions. So very likely this C3, C6 kind of compounds may join to each other. As you can see here, the linkage may be a C-C linkage, but in some cases you might also come across a C-O linkage where there might be some oxygen like atom located in between two phenylpropanoid moieties. So the linkage majority of the times is a CC linkage, but you might also come across a molecule which has a CO linkage. So previously when you saw a compound called as your silymarin derivative, we called it as flavolignan, and that flavolignan, the lignan moiety was attached by a O linkage. So yes, that it is, and in some cases this lignan derivatives are hydroxylated. So they possess many hydroxyl groups. So they also have phenol like properties, that is antibacterial properties. So just to summarize, lignans are dimers of phenylpropanoids. They are often joined by C-C linkage, in some cases C-O linkages. They are biosynthesized from shikimic acid pathway and known to possess lot of phenolic hydroxy groups. Now their occurrence, they occur in numerous plants such as sesame, linseed, soy, sunflower, especially in the seed regions. You can see them in your cereals. They occur in cereals such as oats, rye and barley. Some fruits such as grapefruit or your pear or your blackberries are known to contain your lignans, and in cases of vegetables, especially a cucumber, cauliflower and carrots are some of the vegetables which are rich in lignans. Now what are lignans and how do you classify them? As discussed, your lignans are something which is C3, C6 into 2. Your lignans can be classified based on the nature. So phenylpropanoids, that is C6, C3, if they are joined by 8 linkages. So just showing here, you can say your 8 linkages are this 8 and 8 dash. So how do you come across this ones? And there are few examples herein. So this is your 1, 2, 3, 4, 5, 6. This is called as 7, this is 8, this is 9. So this is 8 and this is 8 dash. Whereas when you are seeing your neolignans may be associated by 3 dash. So in this case, let's put it again 1, 2, 3 with 1 dash, 2 dash, 3 dash. So here there is what is called as a 3-3 linkage, or in some cases there is a 3-8 linkage. So let's see here 1, 2, 3. So now this 3 is attached. So if you remember, this is all 6 and then you go 7 dash, 8 dash. So here the linkage is a 3-8 dash. So lignans are mostly 8-8 linkages. Neolignans are 3-3 dash linkages or 3-8 dash linkages. Norlignans, what you principally observe is one of the methyl goes missing or eliminated in the process, and as a result, so if you see this carefully, ideally C6, C3 is C9. So C9, if I duplicate it, or C9 if I make it twice, it should be C18. But what happens here is you will just see one 9. The other 9 is missing. So typically norlignans have what is called as diphenylpentane kind of nucleus. So even in this case, imagine if a lignan were there missing this methyl group. Eliminate this methyl group. So one methyl less, wherein the formula of your lignan is not met. So they are not kind of perfectly fitting the lignans, and that is the reason they are called as norlignans. So you have based on the linkages, lignans, neolignans as well as norlignans. Another way of classifying them is basis their ring structure. So chemical classification of lignans classifies lignans as aryl naphthalenes. So whenever you have an aryl group attached to a naphthalene group, so these are your aryl naphthalenes. Then you have your aryl tetralenes, so aryl group attached to a tetralene group. Okay, so you have aryl naphthalene, aryl tetralene. Then you have dibenzyl butane. So this is your benzyl group. Okay, so one benzyl, second benzyl. I'm just putting it like that. So these are two benzyls, and here you have your 1, 2, 3, 4. So you have what is called as dibenzyl butane group. Now this dibenzyl butane group may further cyclize and oxidize to form a lactone. In that case, you categorize this as dibenzyl butyrolactone derivative. So what has happened essentially is the same structure. What we are doing is we are adding a little lactone group here and a ring structure. So that is your dibenzyl butyrolactone. So when we go to the next one is dibenzocyclooctadienes. Now in dibenzocyclooctadienes, what happens is I can break this molecule symmetrically into two parts. Now this is my 1, this is my 1 dash, this is my 2 and this is my 2 dash. So this is a typically 2 dash linkages, and what happens here is a 2 dash linkage, but if you see in both cases they are symmetrically balanced. So you have exact symmetric molecule, but when they join to each other they give rise to a octadiene kind of structure, and this diene is contributed to this 1, 2 and 1 dash 2 dash linkages. Now moving down, sometimes they condense and form what are called as furan derivatives. So depending upon that, you have different types of tetrahydrofurans. So you can see in 3 different ways you can have tetrahydrofuran derivatives, and in some cases you can just carefully see, you can split it exactly like this from the symmetry. Still you have your phenyl propane, that is 1, 2, 3. In this case you can call it as we define it as 7, 8, 9, and this is your 7, 8, 9. So here what you see is, again put it as a dash because it's a second group, and these are 2 phenyl propanoid joining to each other in a 8 dash manner, but because of the oxygen moiety substitution and double ring formation, you call them as fluorofuran derivatives. So chemically your lignans can be classified as aryl naphthalenes, aryl tetralenes, dibenzyl butanes, and when they form lactone you have dibenzyl butyrolactones, then you have dibenzocyclooctadiene, then you have your furan derivatives, especially your tetrahydrofuran derivatives, and then you have your furanofuran derivatives. Now let's see some examples of drug containing lignans. Now lignans, owing to their properties, especially cytotoxic and antioxidant activities, are known very effectively in cancers. Now you can see drugs, and a lot of these drugs have been investigated for their study as anti-cancer agent, and one of a good drug in this case is your podophyllum. Apart from podophyllum, we will also discuss other drugs which contains lignans, that is your linseed, cubeb, that is your Piper cubeba, and sesame. So let's discuss your podophyllum. Now podophyllum is a very temperate plant which grows in US and the Himalayan region of India. It's called as American mandrake or May apple because of its beautiful reddish color fruits. The drug of commerce is actually obtained from the underground parts, that is, it is obtained from dried roots and rhizomes of, depending upon the location. If you are saying your American podophyllum, it comes from your Podophyllum peltatum, and if you are talking about the Indian or the Asian podophyllum, it comes from 2 species, that is Podophyllum hexandrium and your Podophyllum immodi. Now both of these belong to a Berberdaceae family member, and you will find them flowering during the seasons, especially your autumn seasons. That's when the rhizomes are taken, sliced, dried, and sold in market. Now commercially, if you see American podophyllum, it's cultivated in the regions of US and Canada, whereas Indian podophyllum is more throughout the Himalayan belt. So you find it collected from the regions of Jammu Kashmir, Himachal Pradesh, Uttarakhand, and even to the regions and in some regions of Sikkim. Now there is a little difference between your American and Indian podophyllum. So your American podophyllum, which is your Podophyllum peltatum, has like calcium oxalate clusters, and these clusters are slightly bigger as compared to your Indian varieties. So the smallest being your 30 micron in size, or the largest being your 100 micron, with an average size of calcium oxalate between 60 microns. Whereas if you see the Indian variant, the smallest size is about 20 micron, largest is 60, and the average size goes somewhere up to 30 micron. Your American one shows more of a simple solitary isolated starch grains, which are about 3 to 25 micron with an average of 15 micron in size, whereas the Indian variant shows more stuck or what are called as compound starch grains, and they have a size little between 2 to 34, but if you see the average is more on the lower side. So the average ranges somewhere between your 7 microns. Now if you see the American variety, they are like about little bigger, 5 to 20 centimeter long, and almost 5 to 6 centimeter thick. So they are very thick and fat and very cylindrical, whereas the Indian ones are very thin. So they are just small, 2 to 4 centimeter long and very tiny, just 1 to 2 centimeter in their diameter. The American one shows a little longer internodes, that is the distance between two internodes is very big, whereas the Indian variant shows a little shorter distance between the internodes. Now coming to a commerce, when you see the resin yields of the American variety is comparatively less. So it just gives you about 2 to 8% of resin as opposed to the Indian variant, which gives 6 to 12%. But American variety is still considered as better variant, because if you see the main lignan, the podophyllatoxin content in the resin, it is higher in the American variety and may go up to as high as 40%. So imagine more than like half of the resin is made up of podophyllatoxin, which we want, whereas Indian variety, the podophyllatoxin content is found to be relatively less. So despite giving more resin, the yields of the podophyllatoxin remain still comparatively less. So, purchase or of commerce, the American variety is considered to be more superior. Now, what does it contain? Now, this contains about like on an average 2 to 8% resin, and this resin is called as podophyllin. Now, this podophyllin is generally collected by extracting the roots in alcohol. So, you will get most of the resin being dissolved in alcohol and then precipitating it by pouring the alcoholic extract in water. Now, these compounds which are there, the resinous compounds which are there, are insoluble in water, and as a result they precipitate out. So, whatever is precipitated out is collected and is used as resin. Now, this resin is a very rich source of compounds called as podophyllatoxin, peltatins and podophyllatoxin derivatives. So, if you see your structure carefully again, this is your main lignan moiety 1. So, I will put here as my lignan 1. So, this is the phenyl moiety of it, and where does the propane go? So, I am putting it as 7, 8, 9. So, now C6 is there, you have your 7, 8, 9, which is the bigger part of the ring. Now, the second part of the phenyl propanoid is this part. So, again once we carefully analyze, this is the C6 part of it. Let me put this as 7 dash, 8 dash. So, it is again a 8, 8 dash linkage, and the ninth is something which is a carboxylic acid, which has been involved or formed or gets into what is called as lactonization. Now, depending upon the substitution, you call different compounds. So, say for example, in this case where your R1 is this, it is a hydrogen, your R2 is a hydroxyl, and your R3, that is here, it is a methyl. So, you get what is called as trimethoxy derivative, and your R2 is hydroxy derivative. In that case, you call the compound as podophyllatoxin, and podophyllatoxin is the main lignan which is present in your podophyllum. Apart from that, if you remove the methyl group from here and just replace by a hydroxy group, you get what is called as a desmethyl podophyllatoxin. So, desmethyl means removal of methyl. At the same time, if you remove a hydroxy group from here, you get what is called as desoxy. So, here it is normally hydroxy in your podophyllatoxin. So, if you remove that also, you will get what is called as desoxy podophyllatoxin. Now, apart from that, you also have a podophyllatoxone in case it forms a ketone rather than a alcohol. Now, just shift the hydroxy group from R2 to R1. Earlier what happened is this was H, this was OH. So, I am just pointing out. Earlier this was H and this was a hydroxy group. I just interchange now this, let this take H and let this take an OH. You get the compounds which are called as peltatins. So, suppose if it is like your podophyllatoxin but just missing or replacing the hydroxy group, you call it as beta peltatin. But if you remove the methoxy, like your desmethyl podophyllatoxin, and then you replace the H, you call it as alpha peltatin. So, these are all the lignan derivatives which are present in podophyllum, and they are used as cytotoxic agents. Apart from that, your lignans will also contain quercetin and starch. So, let us see some applications Like I said, it is cytotoxic in nature. So it arrests what is called as cell replication. So your cancer cells cannot divide, and therefore it's toxic to the cancer cells. Now because it is cytotoxic, it is also used in treatment of venereal or other warts. So you can easily get off those warts by applying little bit of this podophyllum resin there in form of ointment or in form of a little drop out there. Now this podophyllotocin causes a lot of gastric irritation, and as a result it is very effective as purgative. But if you want the anti-cancer activity of it, we don't want GI irritation, we want more of absorption. So as a result, what was done is, if you remember your podophyllotocin, this was a hydroxy. So if you attach a sugar moieties out here, a little polar functionality to it, this compound is called as etoposide, and etoposide is much better absorbed as compared to your podophyllotocin. Also, if you replace this by your thiophene moiety, you get what is called as teniposide. So etoposide is used for treatment of lung and testicular cancer, whereas your teniposide is more used for your lymphoblastic leukemia. Like I said, it's very strong irritant and a purgative, but nowadays they are better and more safer drugs. So it's replaced by Senna, it's replaced by Isabgol, and nowadays podophyllotocin is no longer used as a purgative agent. Now moving on to the next drug is a beautiful seed called as your linseed or flaxseed. We have it in our day-to-day kitchens. It's also known as alsi or javas. Now it's actually a ripe seed obtained from Linum usitatissimum. It's a Linaceae family member. So it's a commonly grown crop in India. It's cultivated in America, Algeria, US, Canada, England, Russia. You'll see it in the temperate regions also of Greece, Italy, Spain, because of its vivid applications and good amount of compounds. So those who eat linseed or flax seeds very well know the advantages of it, and they are attributed to a lot of compounds which are present in linseed. So let's see what's inside this beautiful seed. So linseed predominantly contains oil, and this is one of the best oils when you have to see your omega-3 fatty acids. Linseed contains about 30 to 40% fixed oil, of which majority is your linolenic acid, which is 30 to 50%. So majority omega-3 fatty acid, about 50%. Then you have your linoleic acid, which is about 23 to 24%, and oleic acid, which is 10 to 18%. Now this, if you see, all of them are unsaturated fatty acids. So if you see the total percentage of PUFA, that is polyunsaturated fatty acid, it's much higher. Now when you consume the seeds, you will come across mucilaginous, that is the sticky matter, and this mucilaginous matter is made up of uronic acids as well as sugars. So when you see the neutral fraction of the mucilage, it's made up of arabinose, xylose, galactose, whereas the acidic functions include sugars such as rhamnose, fucose, galactose, and the galacturonic acid, which is the acidic moiety. The protein is a good fraction of it, almost 25%, containing your linen and choline. Whereas if you go to see lignans, the main part of it is a lignan called as secoisolaricinol diglucoside. Now this is a secoisolaricinol. Secoisolaricinol is the main lignan component out here. Again, you can see the nature of linkages. So this is 7, this is 8. So again, this will be 7 dash, this will be 8 dash. So it is a 8 dash linkages. Now here to that, the ultimate, that is the 9 and 9 dash hydroxy groups, you have sugars attached to it, and that makes it much more polar. Apart from SDG, that is your secoisolaricinol diglucoside, you also have pinoresinol, lariciresinol, and matiaresinol. Apart from that, previously when we studied cyanogenetic glycosides, we know there is a cyanogenetic glycoside called as linamarin, which is also present in linseed. Now linseed is also cultivated for its fibers, so that is also something which is there in the seed coat also. Now going to the applications. Now focusing on the lignan part of it, secoisolariceresinol diglucosides and matieresinol, it is found that when you consume linseed are converted by the gut bacteria into compounds such as enterolignans or enterodiols or even enterolactones. Now this have a little phytoestrogen like activity. In some cases they might show a mimicking activity, in some cases they might not mimic it, leading to inhibitory activity. Now mostly the mimicking activity is observed in case of SDG, and as a result they act as mild phytoestrogens. They say that the other like phytoestrogen like activities or non-steroid type estrogen like activities may be due to other effects of the lignans on the different systems of body. But moreover, all these effects are known to prevent or exhibit cancer protective activities. Your linseeds are very good sources of polyunsaturated fatty acids, so they are good for your heart. The oil is also externally applied for your gout and rheumatic swellings. They treat it well, whereas the linseed is given to children, and especially the boiled mucilaginous infusion is given to children because of its mucolytic activity. When chewed, it also gives you a little demulcent effect, which is good for your colds, cough and bronchial affection. So these are few applications of your linseed. Now moving on to the next drug is cubeb, or also called as your Piper cubeba kebab chini. Now this is a herb, or this is actually a berry which is used in Ayurveda as well as Unani system of medicine. What is done is, from the vines of Piper cubeb, this unripe berries are taken. They are dried in a manner very similar to your black pepper, and once they are dried they are used as a source of Piper cubeb. Now this is something which grows very abundantly in Southeast Asia, Indonesia and especially Malaysian regions. So Indonesia, Malaysia and Southeast Asia are the principal producers of Piper cubeb. Now what does this contain in terms of lignan? So if you see the chemical composition, the chief lignan which is present, the most uh, early discovered lignan is your cubebin. So again you can see here, this is 7, 8, I can put here as 8 dash, 9, 9 dash. So it's again a linkage giving rise to a furan ring in between, and from cubebin you have other cubebin derivatives such as cubebinolide, cubebinone, clusin. Also you get derivatives such as henokainin. So henokainin is again a 8-8 linkage, but rather than forming just a furan, it gives rise to a lactone kind of structure. Not only that, there's an additional methoxy substitution out here, and which gives rise to an additional ring formation in both of these cases. Apart from that, you have your cadsurin, cadsurin A and piperinone. Now apart from that, you will see your Piper cubeb essential oil is also used. It is used in perfumery, it is also used in therapeutics. And from the fruits you get phenolic compounds such as rutin, catechin and gallic acid. So all in all, your Piper cubeb traditionally, that is in Ayurveda and Unani system of medicine, because of the lignans and because of the flavonoid derivatives, have been very beneficial in treatment of gonorrhea, dysentery, syphilis, abdominal pain, diarrhea, or the inflammation, enteritis. Even for asthmatic disease condition, it is proven to be beneficial. Now with more and more research going into the lignan derivatives, numerous lignans have been studied for their anti-cancer and antimicrobial effect. Of that, your cubebin was showing a very promising or interesting activity again Trypanosomia cruzi, which is responsible for the Chagas disease. Now the other lignans also show anti-cancer effect, and that's the reason you will see numerous research reports wherein anti-cancer or even certain cancer preventive activities have been shown by the lignans present in your Piper cubeb. Traditionally, it also shows anti-inflammatory, hepatoprotective and antibacterial activities. Now moving on to the last drug of this category, the sesame seeds. Now sesame seeds you already dealt with when we studied lipids, that is we studied the sesame oil. So you get sesame seeds, and if you know, your sesame seeds are of two types. You have the white sesame seeds and black sesame seeds. They come from the same plant, that is your Sesamum indicum, which belongs to the Pedalaceae family, but black sesame seeds have their hull intact, whereas if you remove the hull, you get the internal seed, and that's your white sesame seed. Now if you press it, you get what is called as sesame oil, which is rich in lignans. So you know, like in oil you get almost 1% sesamin, and they are derivatives of lignans. If you carefully analyze, they are furofuran types, and here you can see it when we discussed it. This is 7, 8, 9. Here you have 7 dash, 8 dash, 9. So again you will see most of the linkages are 8, 8 dash type. But interestingly, when you go to sesamolin, it's not a continuous phenyl propanoid like here. The bond has been interrupted here, and that gives rise. So if you break here, you get what is called as sesamol. Okay. So sesamol is obtained from sesamolin, and you know, like sesamolinol is also another derivative which occurs in your sesame oil. So sesame oil is used, or it contains beneficial lignans. If you know the Ayurvedic preparations, most of the Ayurvedic preparations use sesame oil as a base oil for its stability and enhanced therapeutic effects. Now if you see the lignans, you can easily check for the presence of lignans, especially the sesamolin or free alcohol, which comes after breaking the sesamolin, that is your sesamol. So the simple test is your Bowden's test. So Bowden's test is when you take the oil and shake it with about HCl containing 1% sucrose. On shaking, gradually you will see that it turns to pink color, and that pink color is attributed to a reaction of sesamol with your sugars in presence of HCl. Now same test can be observed with furfural instead of sucrose. So rather than adding sucrose, if you add furfural, this is called as your Villavacchia test. You studied this previously as a test to check the identity of sesame oil, and this is basically attributed to your sesamolin or free sesamol. Now coming to applications, your sesamin is a very potent anti-inflammatory compound. It shows antioxidant activities, and like your categories of lignans, it shows a potential anti-cancer properties. It is said that if you have a diet which is rich in lignans, it helps regulate your blood pressure, your lipid profile, and prevent cardiovascular disease condition. Now numerous research also shows wherein your sesamin is able to inhibit your cancer cell proliferation and induce apoptosis, especially in the cancerous cells. So it can be cytotoxic to the cancerous cells and therefore show beneficial activity in prevention as well as in management of cancers. So here are a few references if you wish to read more about this set of compounds, and thank you everyone for your patient listening.